Hi everyone, I'm Akram. In this video assignment presentation, I would like to talk to you about the graphs and solutions of quadratic equations with different inputs. So, without further ado, let's get straight into this video.
So for question 1, I've input all the values for y equals to x squared plus bx plus c using the spreadsheet formula. So when b equals to 6 and c equals to 4 and x equals to -5, we can see that the value is equals to -1. So let's change b and c. We can see that the value here changed from -1 to -7. For question 2, as you can see, there is two curves in the graph chart table. The blue one representing y equals to x squared, and the orange representing y equals to x squared plus bx plus c. The curves are made with the values in the table on the left hand side of the Excel sheet. Observe the orange curve when b equals to 6 and c equals to 4. As you can see, the blue curve did not change, whereas the orange curve changed according to the new b and c inputs that I have keyed in. For question 3, the numeric discriminant is derived from the quadratic formula, specifically b squared minus 4ac. To find this, we get the values from the table of values and inputs b and c, accordingly based on the formula ax squared plus bx plus c. After which, we will get a equals to 1, b equals to 6, and c equals to 4. After getting these values, we find the numeric discriminant, we will get 20. And to find the numeric solutions, we must use the quadratic formula itself. The first x solution will be -0.76393, and the second solution being -5.23607. And we can see that if we change the inputs of b and c, the numeric discriminant changes along with the solutions as well. For question 4, we will input the values of b and c into the complete the square formula. We will get y equals to bracket x plus 3 bracket square minus 5. To know whether the graph shifts to the left or right, we must look at the number inside the bracket. And in this case, it is a positive 3. A positive value means that the graph shifts to the left. Value is negative, the graph will shift to the right. So since the value is positive 3, the graph will shift to the left by 3 units. Compared to the blue curve, the orange curve shifted to the left by 3 units. To see whether the graph shifts up or down, we must look at the value outside the bracket. In this case, -5. If the value outside the bracket is negative, the graph will shift downwards. And if the value is positive, the graph will shift upwards. In this case, the value is -5. Thus, the graph will shift down by 5 units, as you can see in the graph chart table here. Discriminant values have 3 types. These 3 types will produce different solutions. For the first one, if the discriminant value is more than 0, it will produce 2 real solutions. This means that the graph intersects the x-axis at 2 different points, and these 2 points represent the 2 real solutions. Secondly, if the discriminant value is equal to 0, the equation will only produce 1 real solution. Thus, this also means that the graph touches the x-axis at only 1 point. This point is the coordinate of the 1 real solution produced. Lastly, if the discriminant value is less than 0, the equation will produce no real solution. This is because the graph does not intersect the x-axis at any point. Thus, in conclusion, the discriminant value determines what type of solutions you'll get and whether the graph intersects at the x-axis point or not.
That is all for my presentation today. I hope you have enjoyed watching and learned something new. Thank you for taking your time to watch this video, and have a nice day ahead. Bye!